Hello and welcome back to Physics for the 21st Century. My name is Greg Perugini and I'm your lecturer and guide through this course. And this topic is about kinematic variables and notation. We've already introduced in the previous topics about units, how to manipulate the units, how to use dimension analysis. Now we're going to use units to calculate other variables, to derive other variables. So we can look at units and we can look at variables in two different flavors. We have scalars, which have a magnitude: mass, speed, time, and distance. These all have magnitude. For speed, for instance, I could be going down the highway in my car, and if I'm pulled over by a cop, he doesn't care whether I'm going east, west, north, or south. My speed matters to him. Velocity, on the other hand, has not only magnitude, a certain amount of meters per second, but it has a direction. I'm going east, west, north, south. So in order to describe a vector completely, I have to not only give you its magnitude. If I'm talking about displacement, I'm talking about meters, just like I'd be talking about in a scalar distance as a measurement. Displacement is not only meters in terms of magnitude, but the direction. So as I said, the difference between speed and velocity is the amount of direction or a directional quality to it. Acceleration is a change in velocity. And so we can get this average speed, and we can look at it as a change in distance. Maybe it's a change in x, let's call it, over time. Okay? Now I can, if this x is describing meters in a direction, we're going to call that displacement. So if I am going, say, in this direction, then up in this direction, this distance that we have here, from here to here, is what we're going to call a displacement. This measurement here is a distance, and then I have another distance here, and as you can see here, distance is different than displacement. If we're talking about velocity, this change in distance, this change in displacement, we'll call that, is that figure there. So I'm talking about with speed, the amount of distance traveled, and with velocity, I'm just talking about the displacement. With velocity, of course, I have, and we'll get into this in the next chapter, that I have a displacement from this point here to this point here, called point A to point B. And to describe that completely, I would, of course, have to give you an angle from this direction. So let me review that again. So if I'm talking about velocity, this change in distance, this change in displacement over time, and the units for that is meters per second, is a displacement from point A to B. And we could look at that as being, and we could use this notation, from x initial to x final. If I call this the initial position, and this is the final position of where I ended up. So what you really need to know, though, is that the difference between speed and velocity is that speed does not care about the direction. It is a scalar. Velocity, we care about the direction. You have to describe the direction, whether it be in an angle, as we have here, or maybe it's in 30 degrees or northwest would be a direction, for instance. Now, acceleration, that is a change in velocity for a given period of time. And as they show it here, there's a change from the second position here to the first position. And I can use velocity final, or I should say the change in velocity final versus velocity initial over a time final minus a time initial, a change in time. Okay, so that gives you a little bit of a feel here. So if I have an initial velocity, let's say I'm going at 30 meters per second initially. I'll draw that bigger here. Velocity initial. That's the notation style I'll use. I'm going 30 meters per second. And my velocity final is equal to 10 meters per second. Well, what does that tell you? That clearly tells you I'm decelerating, right? My acceleration would be 10 minus 30, right? Final minus initial. And then we have to say, well, what period of time did we do this over? Let's say my passage of time between these two, the change in time, my t final minus t initial, if we want to look at it that way, the change in time is 5 seconds between these two. Pick it up there like that. So what you clearly see is that my acceleration then is negative 20 over 5, or negative 4 meters per second squared. I am decelerating. So when I talk about motion, decelerating, changing in velocity, changing in time, changing in acceleration, I'm really concerned with motion and kinematics only with those 4 variables. time, displacement, velocity, and acceleration. And I've already introduced those variables. Typically, velocity final, as described, this is velocity final, if I have, for instance, an airplane that is coming to a stop, okay, it is going, say, 100 meters per second when it hits the runway. And then it comes to a stop, in 20 seconds. Well, what are we saying with that? First of all, just like in the previous example, we have a deceleration. And one of the things you want to get out of this course is that you'll have these English language problems, and you have to pull the variables out and use the proper equations with them. We'll introduce the kinematic equations in a subsequent topic. But when I say I hit the runway at 100 meters per second, that is going to be my velocity initial. If I come to a stop, I am really saying there that my velocity final is 0. And my change in time is pretty straightforward at 20. So that's a little bit about how we are going to use our notations here. Velocity with a subscript of a f, velocity with subscript of an I, x initial, x final. X can be in any dimension, x, y, or z. Many books will call this S to ensure that you're aware of and covering just to be aware that you can be covering this in any dimension, not just x, but in y and z as well. So they sometimes call it an S. But I'll just stay with the x value, and you know that I'm talking about displacement for that. So we're going to use all three of these variables in our kinematic equations. In the next class, we'll do a review of how these variables will map into Cartesian coordinates and look at all the geometry and the trigonometry that you're going to need. And then we're going to move into solving the kinematic equations. Okay? So that's the end of that topic.